There are many ways to collect data, and these are some of the methods of data collection you can use. So 2D imaging is useful for less experienced athletes as it gives them the height and width of the jumps and or swing, etc. However, if they wanted more information, then they would more experienced athletes would use 3D imaging, as it also gives them the depth as well. An elite basketballer would use 3D imaging, especially when doing a skill like shooting, as shown on the screen. This because it will highlight their specific movements and what they're doing well and their weaknesses, which can be worked on in order to make their performance better. For 2D filming, for example, a jump, you must make sure that the camera is perpendicular to the person and that you get their whole body in. Otherwise, you will not be able to see how long they are in the air for and what technique they will be using. In order to get a good image to work from, you need to have a good digital image. This is very important when collecting data, as then you can see each step clearly, which can help to properly identify the strengths and weaknesses of the athlete. This links to 2D and 3D imaging, as you need to have good, clear pictures to get good results. The shutter speed and frame rate. So the frame rate is the number of individual frames that comprises your video per second, and it is measured in frames per second. For super slow motion video, you would have to use a very high speed camera at about 1000 frames per second. As you can see from the picture on the right, the frame rate is very important if you want to get the smallest of the details in the shot, like the grains of sugar in the picture. The shutter speed is simply how quickly the lens on the camera opens and shuts in order to take the picture. The frame rate and shutter speed have to work alongside each other, and if they're not calibrated, then it can make the picture blurry. See the picture on the far left. And if a shutter speed is too fast, then it can make the picture look dark. This because the light isn't being able to get in quick enough, which will cause the pictures to come out dark, so you won't be able to see them very clearly. Alternatively, if the shutter speed is too slow, then too much light could come in, which could also ruin the picture. Horizontal scaling and vertical reference, and then perspective and parallax error. In order to make sure that the camera is the right place, you have to use horizontal scaling. To make sure that the person jumping is bending down to use right angles, let's say 45 degrees, before jumping they'll use a goniometer to make sure that the angle is right. You are vulnerable to perspective error when any type of motion is filmed. To reduce this error, you need to make sure that the camera is perpendicular to the object of interest. You have to make sure that you take all readings at a parallel level to reduce parallax error. You can do this by putting the camera at eye level. Camera setting and positioning. You have to make sure that you get the camera set up right, and that you need to take into account the right planes of motion in order to get it right. There are 3 planes of motion: transverse, which is the y-axis, sagittal x-axis, and frontal, which is z-axis. There are many camera positioning considerations: the distance from the person, the angle of the camera to the subject, the field of view, the image size, and, as I've already mentioned, the planes of motion. So these are some data that we took when we went to Chichester University, and we did 3 different things. So we did vertical jumps, but we did one at 45-degree knee bend, so we had to go down in that position and then jump from there, not allowing to bend down any further. We also did a 90-degree bend, and then did just a normal jump. And as you can see from the graph, this is showing the jump height and then the performer, and all 3. This one is then showing the impulse as well, with the same things: 45-degree, the 90-degree, and the commutative. And what the graphs are really showing on both of them is that the commutative one, which is just your normal one, comes out the highest for both, which is normal because you'll be able to use your arms and legs as much as you can. And the 45-degree one then comes out second, which is because you are not the stretch shorten cycle. If you are down for a long time, then it loses all elasticity, which means you can't push up as much and get as much force you want to, and so the 90-degree bend will not come out as much for most normal people. as you're having to stay down into that position for longer. That's it.